So, in your opinion and based on your experience, have the tools maybe gotten easier or more accessible for somebody who is just getting into FPGA development?
Yeah, I think the tools are easier to get hold of, right? So there's of all the vendors these days, you can pretty much go to their website and you can download the tools. You might have to create an account, but you can download the tools for free, and you can use a fairly reasonable size range of FPGAs that come with that. 20 years ago when I was just starting out as a graduate, when you want to be practicing, might want to have some side quests, do it of an evening, you couldn't do that. So I think the tools being more available is has made a big difference to adoption.
Hello, everyone, and welcome to the Altium OnTrack Podcast. I'm your host, Zach Peterson. Today, we're talking with Adam Taylor, founder of Adiuvo Engineering. Adam Taylor is also the founder, or I guess the lead behind FPGA Horizons. I'm also very interested to talk to him about that. And if you're going to be at this year's PCB East conference, you'll have a chance to, I believe, link up with Adam and learn more about FPGA Horizons. So I'm very excited to talk to him today. Adam, thank you so much for being with us.
No problem. Thank you very much for having me on today.
Yeah, absolutely. I regard you as somewhat of an influencer in FPGA. Some people hate that term. I hate that term, but
I cannot stand that term.
yeah. But the gods that crafted the social media algorithms have decided that I must know about you. So therefore, you are here today. So
Well,
if you
that's
could.
good that you must have to know about me.
Yeah, right. I guess you can't complain. If you could, just as a new guest, give us an overview of your background, how you got into electronics.
Yeah, of course I can. So I guess I've been doing sort of FPGA electronic engineering for sort of 26 years or so now. So I did the classical thing, went to university, got an electronic engineering degree, and then just by happenstance sort of fell into FPGA engineering in my first job. They asked me and the other graduate, do you know anything about FPGAs? He said no. I said yes, and the rest is history. Over the years, I've designed several boards as well. We do design boards, but predominantly we do sort of FPGAs and sort of embedded software, really.
Okay. So, I guess that's kind of interesting because it's always nice to hear about people's backgrounds and paths into electronics, and it sounds like you just kind of fell into FPGAs, right? It's not something that you really like sought out as part of your educational path.
No, not real, not too much. I mean, you have to remember. So when I went to university, it was literally last century. I mean, I like to think I'm young, and in my head I still am, but I'm nearly 50 now. Well, 48. So I mean, well, I went to university in the 90s. So FPGAs were still, programmable logic. FPGAs were a thing, but they're not quite as not quite as they are today. So we did some FPGA projects at university, and I thought I knew VHDL from what they taught me at university. Obviously, it's like everything, it turns out that you really don't. But yeah, it was an interesting it was one of the more interesting things that we got taught at university. But I never thought I'd end up doing it as a job, if you know what I always figured it would be doing more the traditional electronic design, the schematic design, the PCB layout, and I have done that at times throughout my career, but it's been more FPGA. And like I say, it was literally just happenstance on starting our new company. And do you know anything about VHDL? Yeah.
There you go. The rest is history, right?
Yeah,
I get
exactly. Yeah, the rest is history.
for me it was do you know anything about RF? And like yeah. All right, there you go.
Does
You get the
anybody
job.
does
You get the
any
job.
does anybody know anything about RF? I know enough to know that it's kind of like this black magic thing, right?
That's what they call it. Yeah. Some of us started with RF, and some folks start with power, and they go in opposite directions in terms of the learning path, I guess. So one thing about FPGAs, and this had always been kind of my perception for a long time, at least until I got into industry, was that they were really only useful as like chip prototyping or one-off designs. Is And the more I've looked around, the industry and of course done, commercial
Mhm.
projects, I've of course found that that's really not the case. So what's your opinion on that view about FPGAs?
I think traditionally, FPGAs have been on a very interesting journey. When they first started out, it was literally glue logic, right? Small numbers of programmable logic cells. You could use it to replace some of what you had in your discrete components on your board. I think now, actually, I think they're the heart of many systems. And they've really sort of been on a very interesting journey over the last sort of 26 years. Nowadays they don't just have programmable logic in them. They've got processors in them, AI engines, network on chips. They're really sort of advanced compute systems. So I think obviously for some instances, if you're doing a really high volume, then like a lot of ASICs might be the way. But you'd be amazed how cheap FPGAs get if you buy them in quantities. And the nice thing about FPGA, of course, is you can, and I do this all the time, is you can get it wrong and correct it without having to go through the entire respin of an ASIC and having to admit to your boss that something's not quite right. Which is probably another reason why I prefer them to board design as well, because it's easier to correct your mistakes.
Yeah, or you can compensate for a board level mistake, right? I mean, somebody switched the pins, right, and they got it wrong accidentally, but hey, you can compensate for that in the logic.
That's it. A lot of times, unless you're really unlucky, you can compensate for things like that. And I don't know, it's a very interesting thing, the hardware FPGA board design. Where does it sort of the boundaries of it, shall we say? I think an FPGA engineer should be able to design a board and they should be able to read schematics and feed into layouts and things like that. Because I think you have to understand the entirety of the system.
Yeah, I would agree. I kind of feel the same way about like DFM and manufacturing with board design, right? The board designer doesn't necessarily have to have worked at a manufacturer, but it certainly helps a lot if they know about the process and can, understand things about manufacturing. I would say it's really the same thing with firmware and possibly even FPGA.
It is. I think the more you know, the wider your knowledge is, the more useful you are on a project, shall we say? I think.
Sure, sure. So you mentioned something interesting here, which is kind of the I think the enabler behind broader FPGA adoption has been the breadth of things you can do with FPGAs, right? You mentioned several things there, right? You even mentioned AI engines, and I guess we can tell the AI bubble is returning because we only got 5 minutes into the podcast before somebody mentioned AI. So yeah, AI engines on FPGA is an interesting topic, and there are other features as well. Do you think that's really been one of the major drivers behind using FPGAs and maybe these mid-volume and possibly even high-volume type of applications?
I I think the AI engines are an interesting thing. In fact, most customers come to us and ask us to use them for DSP, not for AI, to be exact, for example. So, um, but I think when it comes to what's driven FPGAs, if I think back throughout my career, the entirety of the solution in a lot of cases, has been a processor talking to some sort of talking to some sort of FPGA. And I think that merging of the two into what a lot of the system on chip devices are today has been a real enabler and a real driver for that, because you get a much smaller solution, shall we say, on your board. You get a much more power efficient solution. You get a lot better performance in terms of EMC, EMI, security as well. You get a much better performance at also. So I think they're moving. That's really what's enabled it, and I think the tools as well. I mean, everybody. If you talk to everybody, they'll tell you that FPGA tools are terrible, and a lot of them that they're not the best, shall we say? But they're way better than they were 20 years ago, and there's a lot more capability in there now, and it's a lot easier to get your hands on them and try them and experiment with them. So I think a lot of people are kind of going with that. That's seen that drive, and I think as the final thing as well, there's an engineering thing in it. I think FPGAs are quite interesting. So if I'm gonna be here's where annoy every board designer in the world, and I don't mean it. But if you're going to design a board, it becomes very like, I'm going to put some power supplies down, I'm going to put memories down, I'm going to put a processor down, I'm going to put an FPGA down. But if you're doing an FPGA and you're actually designing the internals of the FPGA, you're kind of quite creative about what you can do. Obviously, some people go far too creative and make a huge mess of it, but you still get to be a little bit creative as an engineer as well. And I think a lot of people try and like that about FPGA, so they try and, shall we say, work one in so as they can get it on their CV or resume. Sorry for the Americans.
Sure, sure. Now you mentioned something interesting too, which is the tools, and I guess I have two questions there because, um, and I'll preface this by saying, like I always tell people, like I'm not a pro software developer, right? I'm not a pro developer, but I know enough Python to be dangerous, right? And I can make websites, right? So I'm pretty much at the basic level, but when it comes to like FPGA development tools, I couldn't tell you if one is easier than the other. I have to get handheld through by, a developer that I'm working with in order to, really understand what's going on and try to make decisions as far as where the development goes. So, in your opinion and based on your experience, have the tools maybe gotten easier or more accessible for somebody who is just getting into FPGA development?
Yeah, I think the tools are easier to get hold of, right? So there's of all the vendors these days, you can pretty much go to their website and you can download the tools. You might have to create an account, but you can download the tools for free, and you can use a fairly reasonable size range of FPGAs that come with that. 20 years ago when I was just starting out as a graduate, when you want to be practicing, might want to have some side quests, do it of an evening, you couldn't do that. So I think the tools being more available has made a big difference, to adoption. I think the other thing that's out there as well is just the community that's out there now for FPGA design. You can pretty much you can Google most things on an FPGA these days, and you'll find an article or a blog or a question. If you're really unlucky, it'll point to one of mine. But you can find all these, and so there's a huge community of developers as well. And I think that's particularly over the last 10 years. That's really grown. So there's people out there putting stuff out there, which helps you when you want to try and do something, or if you come across something for the first time, then that community's there.
And then the other question I have about the tools, and this is, coming back to AI, of course, AI has kind of, taken over software development with stuff like, Claude Code and Cursor and these kinds of coding assistants or coding agents. I guess they're not assistants anymore. Now they're just going out and doing it. Um, are we seeing that same kind of automation come to FPGA development?
Oh yes, yeah, definitely. I mean, it's weird. There was a point around the back end of last year when the models just got very good.
Yeah.
Before then, you could kind of get it to give you template type code and such like that. Now, actually, there's a real step change, and it's possible to use AI to generate RTL for you. And if you're using the agentic stuff, and you've got the simulators on your thing, you can say, well, here's what I want you to write me. I want you to write me a test bench that proves that it works. And then you can sit and watch it simulate it and prove it. Go, oh no, that's not quite right. I'll tweak that. I'll do this, and get it to drop out with the result. And it's not going anywhere. The worst it is today. I mean, my view, similar to many other engineers. In fact, I was just talking to somebody about it earlier, and I think it is a bubble. And I think we're probably at the limits of what LLMs are going to be able to do for a little while, and scaling is going to be a bit of an issue. But it's not going anywhere. And if you come, like you mentioned, FPGA Horizons earlier on, for example. So FPGA Horizons, just for those that don't know, is a conference that we run in the UK and in the US. And at the US one this time, we're running tutorials on day 2, and AMD are going to be there with their new version of Vivado, which has got AI built into it, and he's going to show you how you can use AI to help you create FPGA designs and leverage FPGA designs, and do things like fix timing constraints and timing issues, or even create sort of like designs for you. So I think that answers you. I think that answers your question. I've rambled a little bit, but yeah, I think AI. It's not going anywhere. and it's one of those things as an engineer. I just view it as another level of abstraction, to be honest. When we first started doing programmable logics, when I learned it at university, we learned Boolean equations. You
Hmm.
do it all in Boolean equations. You program the tool, Boolean equations. That's got a limit on it. So then it moved over to schematic entry, like drawing AND gates and OR gates, just like you would in a real world schematic. Again, that's got a limit on it, which led through to RTLs and HDLs and such like. Then we've seen the move over to like HLS and model-based engineering, and AI is just another level of abstraction on that. I don't think it replaces the engineer. In fact, I think it makes the engineer even more important because you've actually got to know what's going off under the hood and whether the results are right or not.
Yeah, I agree. I also think it's kind of a bifurcator. I'm making up a word here, but I think it'll really create a bifurcation in terms of who's able to do the most advanced, newest things, and of course, they'll benefit from that personally and in terms of their career. And I think there's going to be other folks who just they probably can't keep up with the folks who are the best users of AI. And I think that's something you've seen throughout technological revolutions in the past.
Yeah, I think it's one of the things as an engineer, actually, you should never, you've always got to keep learning and keep developing, right? And keep learning the skills, because if you stand still or stop doing it, then you're effectively going backwards, particularly these days.
Yeah, I would 100% agree. So before we get into talking about FPGA Horizons, we'll get back to the community in just a moment. But
Mhm.
one thing I was really wanting to ask you, as someone who has a lot of experience in this field, is do you think FPGA development is maybe a good career choice or a good career path for young designers, or at minimum a skill they should have in addition to some other sort of engineering skill set?
So I think FPGA design, I think it's fantastic. I think it's genuinely the best career choice you can go as an engineer.
A little
I've had
biased there, right?
a little, I'm slightly biased. But I think about what I've been able to do. I think about what I've been able to do for my career in engineering, and it's kind of incredible. If I start telling people that, a lot of people don't believe me that I actually did a lot of the stuff the paths that it's led me to do. That said, FPGA is great, and knowing how to do them is good. But as I said earlier on, I'm a firm believer that engineers should have a breadth of knowledge, not just a narrow focus of knowledge. So I think that engineers should be able to design boards and design schematics and bring up things and work with manufacturers. I also think engineers should learn about project management and delivery and all that sort of thing, because that's actually quite complex and a lot more challenging than you think. So no, I'm a big fan that actually, I think FPGAs are great, but I think you should have a wider horizon as well. I'd draw the line at mechanical engineering though, because that's just a little bit weird.
Yeah, I'm right there with you, man. 100% agree. But yeah, I really agree, and part of the reason I ask this is because, I get messages from students, maybe they're doing a CS degree and they're considering getting into like board design or possibly chip design or FPGA or embedded, I think they see kind of what's happening with AI and computer science, and they want to know, hey, is engineering like real physical products also kind of going to go the same direction as software engineering? And I always tell people like, well, you should know your core skill set plus at least one other thing and be really good at those two things. You think that's appropriate?
I think that's a good bit of advice actually. I think that's know your skill set plus the adjacent one. Is a good example. And I think, yeah, it's an interesting where the AI is gonna lead for everything. I mean, certainly for like high level software, it's making a huge impact. Um, but there's still challenges to go and still interesting things to do. But certainly, if you can touch something you've made, I think it's a lot more safer, shall we say, at the moment.
For sure, for sure. So let's get back into FPGA Horizons for a moment. So you have started I don't want to call it a company, but I guess you called it a conference called FPGA Horizons. It's run in the UK and in the US. And there's going to be something happening with PCEA this year here in the US at PCB East. And I wanted to see if you could give us an overview of FPGA Horizons.
Yeah, of course I can. Um, because I don't have enough things to do. About last January time, I decided that the one thing the UK is missing is an FPGA conference. Uh, so I talked to the vendors, the main FPGA vendors, the 4 or 5 FPGA vendors, AMD, Altera, Microchip, Lattice, and so on, and asked them if they'd be interested in sponsoring a UK conference. They were. I kind of figured, it'd be me and a big plate of sandwiches and a really expensive hotel room, because it'd be a bit hard to get people to come. But actually, it took on a real life of its own. It was crazy. We had sort of 300 people there on the day. I had to turn away 200 people in the last month because registration, we literally couldn't fit any more people in. And this was in sort of central London. Fantastic day. I'll send you some links if you want to what it was like. But basically, a day of very technical talks. I mean, we were very keen, no marketing, technical talks, and then like a demo show floor area. And because of this, when I said I was going to do one in the UK, a few people said, "Can you do one in the US?" And obviously, it's a little bit more tricky in the US because in the UK, I've got a company there. We can do things there. So in the US, we've partnered with PCEA, who've done all of the sort of the business side of it, shall we say. All we have to do is turn up and give I have to just turn up and give the presentation I'm going to give, like I would be talking at any other conference. So PCA have handled everything for that. And that's going to be in Boston at the end of the month. Again, we've got all of the vendors are there, so like AMD, Altera, Microchip, Lattice. We've got MathWorks there as well. We've got a huge list of people coming. And then again, there's technical talks throughout the day, aiming to teach you how to be a better engineer. And then on day 2, like I say, AMD are going to run a workshop on the second day, sort of like a hands-on workshop, a sneak peek of their new latest and greatest FPGA development tools. So hopefully it should be. I'm quite excited by it. It should be a good conference in the US, and then we'll have another one in the UK in October time as well. So it should be. But I've had to learn a lot. You know, as an engineer, I've had to learn a lot about how to put on a conference. So it's not me that does this. I have a team of people that, like an events manager and things like that, that do the conference. So, like Louise and Susie and Matt, I can't thank them enough for actually turning this random idea into something that's actually viable and people can attend.
That's awesome. That's awesome. So I guess congratulations are in order for putting on such a great first run of that conference in the UK, and good to know that it wasn't just you standing over a big plate of sandwiches.
Well, it might be in the US, yeah. We just don't know, do we?
Well, you've gotten a lot of penetration for the promotion. I noticed, and I'm sure other people have noticed as well. So, hopefully it's going to be a great turnout. And to anyone that's listening and watching on YouTube, make sure to check out the description for this video, and we'll put some links there in the description so you can go learn more about FPGA Horizons. So I'm kind of interested to learn how you hooked up with PCEA and why they wanted to work with you on this, because PCEA doesn't normally look at component level stuff, right? It's a lot of board design and then manufacturing, and typically in the past when they've done these kind of like partnerships with anyone or like a partner event kind of thing, it's been with a manufacturer, or a manufacturer has sponsored it, that kind of thing, and that's usually been the focus. So I'm really interested. What did they see in FPGA Horizons that made them think that this was going to be a great draw?
That's a fantastic question. I mean, obviously, I'd like to think that the sort of like the buzz, the community vibe around it in the UK, was something that led PCEA to think that it'd be a good thing to partner with in the US. But I think there's an interesting element, although we talk about putting FPGA components and on boards, I think the board designers and the FPGA designers, they have to work closer together than they ever have done before. Particularly as we go, one of the sessions we've got is about 112 gigabit per second signaling. You can't do that in isolation. So I think it brings together a nice group of a nice bringing together of technologies, really. The people that design the boards, the people that design the FPGAs, and bringing it together. So I think the PCA saw there was some synergy there, and that it would align really well. Hopefully, it would align with the audience and the market that they were trying to reach out to and address.
Yeah, and you brought up working at 112 gigabits per second, and then also I think the next generation 224, and now everyone's talking about 448. It's all going to end up in FPGAs at some point. So yeah, I think that makes a lot of sense. But you mentioned the collaboration aspect, right? The board designers needing to work more closely with the FPGA developers. What are some of the challenges that you've seen in the past, or maybe some of the defects that have come up when board designers and FPGA people don't work together?
Well, I mean, when you don't work together, it normally doesn't work too well, does it? Pins aren't allocated, power's not provided. The I/O voltages aren't quite correct.
Well, I guess what I'm asking is I guess what I'm asking is why does over-the-wall engineering not work with FPGA?
I get that. I was being a little flippant, to be fair. But I don't think over the wall works with most approaches, shall we say. But I think with FPGA it's particularly difficult because the pins within reason can pretty much do anything. But there are tight rules on banking, and on particular pins you can use for certain things, particularly like, for example, on a DDR4 interface. There's rules about byte groups and nibbles and things like that you've got to take into account. So if you're just kind of doing the throwing it over the wall sort of thing, it doesn't work too well, because it's easy for a miscommunication or a misunderstanding to lead to some sort of fundamental issue in the design that causes issues later on. And similarly with things like power dissipation, the FPGA power dissipation will depend greatly upon what I put in it and the clock frequency that it runs at, which then echoes back to the power dissipation and the power architecture that the designer's got to implement to make sure it can power that FPGA across all its use cases. It's not quite as simple as being able to look things up in a data sheet and go, aha, the answer is this, because it's so flexible.
So in terms of what's a development process with FPGAs and boards, I have worked on multiple projects with FPGAs, and I've seen it happen two ways, right? I've seen the FPGA folks go first and define what has to happen on the board. So it's usually with pin assignments and power selection. And then I've seen it go the other direction, where the board designers just come up with the schematics, and they may accept that they have to make changes if the FPGA person calls them out, but they're basically sending it downstream to the FPGA guy while they work on the layout. What are some of the problems with that? It looks like you just kind of did the kind of motion.
I was just thinking like, how do I answer this? Because obviously, as the FPGA guy, my solution is, as the FPGA guy, I want to tell everybody, I want to tell them what the pins are and what the power is. Actually, I'm pragmatic as well, so you have to. The reality depends upon the projects that the projects that you're working on, the timescales that you've got, and the constraints that you've got in the real world. For really complex, high performance FPGAs, I would expect the FPGA team to be leading it and telling you what the pins are, because that's going to be that pin out is going to be very tied to the timing closure that you can get inside of the FPGA. And moving those pins about pin swapping, things like that might cause issues, might cause timing issues. And if they've already done the schematics and you're like, well, no, we need to do it completely differently, then that's just going to cause unnecessary pain, shall we say, to to the schematic team, to the hardware team that are doing it. If it's not quite so cutting edge and it's a smaller type device, then I could see people saying, well, this is what I've read the data sheet. It's a fairly small pin device, and I do this with Thomas quite often actually when we're developing boards to each other. I'll kind of give him the 10,000-foot view, and then he'll go away with some schematics and come back and say, this is what we've got. Is it okay? And you can take that through pin planning and check. You can check that that's a viable design, or a viable pin out anyway, relatively easily in the design tools these days. So it's like everything. There's a million and one ways. There's a million and one ways to do it, and it just depends upon the complexity. I think it depends upon the complexity of what you're trying to do, particularly in the FPGA.
Sure, that makes sense. Another thing that I wanted to ask is with FPGA development is IP development. There seems to be a lot of IP coming out over the years that makes it easier for let's say a board designer to be able to quickly locate what pins are going to be used for which interfaces. And at least if you maybe aren't even an FPGA developer, you could maybe talk to, let's say, an applications engineer at the vendor, right? Or at one of the distributors, right? So there's, a guy from Avnet, for example, that I've talked to many times who's been very helpful with this. But one of the things that I think makes that really challenging is that this information doesn't make its way back into the PCB tool, which is typically where the board designer spends, 80% of their time. So do you think there's value in like getting all of that IP information and interface information and, the possible functions of all the different pins into the PCB tools? Because it seems like this was a big focus I'd say maybe 10 years ago. And then at some point it just kind of got sidelined. Altium doesn't do it anymore. And Siemens kind of mentions FPGA stuff, but they don't, really push it very hard.
Yeah, there was a course I went on years ago for Siemens, like about IO designer or something like that. It did the schematics and the FPGA constraints, I think, at the same time, and tried to keep them in sync. Yeah, I think it's a difficult one. I mean, to be honest, these days most of the FPGA tools will have a pin planning, so you can go through and do pin planning without having to go through all the way through time enclosure and having the design and seeing whether that's going to work or not. It's a tricky one. There's definitely a gap there, shall we say? There's definitely a gap and a disconnect there where there's manual processors coming. FPGA engineers and hardware engineers have to communicate to fill that gap.
Yeah, I've wondered if there's going to be kind of this meeting of the minds, I guess you could say, again, because of some of the complexity that you've mentioned with FPGAs and the fact that they're making their way into more complex systems and how it drives board designs. I'm just a little surprised that some of these tools haven't really been resurrected. And maybe FPGA Horizons will help to kind of push that idea a little bit.
Well, maybe we can get people talking, right? That's what it's all about. Get people talking and sharing ideas and expressing sort of challenges that we face, right? And I think as engineers we're particularly bad in thinking about that we're the only person that ever faces this challenge, or our industry or our industry segment is the only people that ever see this challenge. So we don't necessarily talk about it and share about it. Sometimes though, when you do that, the conversation is, oh, actually that's really simple. We could just do X, Y, and Z, and this solves the issue. Or, oh, hey, yeah, we came across that and we solved it like this. So this is why conferences like PCB East, FPGA Horizons, the community side of things is so important, because the more you share ideas, the more things are likely to happen.
Yeah, those are great points, and it's just one of the many reasons I recommend to designers, especially new designers, to go to these conferences. It's not just a learning opportunity for kind of basic stuff, but it's also a chance to possibly get involved in pushing the industry to where it needs to go. So definitely hope folks will show up to those conferences and start showing up for FPGA Horizons. One last question I have about FPGA Horizons before we wrap up is, where do you see it going in the future?
That's a great question. I think we'll be running these given the interest in them and the likes of them. I think we'll be running these for the foreseeable future. We're obviously running one in the US now. We're running one in the UK now. Whether we run one elsewhere in the world, maybe the Far East or something like that, I don't know yet. But it's something that we're thinking about. But at the moment, I just kind of want to sort of grow the ones in the US and the UK and see where it goes from, there, because it's quite different to growing or running an engineering company, shall we say.
For sure. Well, once again, I hope folks that are out there that are listening and watching on YouTube, head over to the YouTube video, make sure to open up that video description, and you'll be able to get access to some links to learn about FPGA Horizons. Adam, this has been a very cool discussion. I've learned a lot. I hope all of our viewers have learned a lot. So I want to thank you for coming on to the show today. And as FPGA Horizons develops and grows, we would love to have you come back on and talk to us again.
No, I would love to come back. Thank you very much for having me in the conversation today. And yeah, it's been
Absolutely.
Good fun.
Thank you very much. To everyone that's out there listening, we've been talking with Adam Taylor, founder of Adiuvo Engineering. If you're watching on YouTube, make sure to hit the like button, hit the subscribe button. You'll be able to keep up with all of our podcast episodes and tutorials as they come out. And last but not least, don't stop learning, stay on track, and we'll see you next time. Thanks, everyone.